So this is Don Grayson. He is a 92-year-old young man, and he was an engineer for naval avionics for over 30 years, I believe, and now is retired. And he was a boatsman, a gardener, a tinkerer, and somebody who does a lot of things. So I'm just going to, this is his daughter, Melinda. I've been a member of Mensa for, oh gosh, I don't know, a good long while. And so I brought him to the Chicago area Mensa where he gave this talk. And he had such a good time that he's giving it again. And I hope that you guys enjoy it. I'm really proud of my dad, and I'm glad that he's able to do this. So this is my dad, Don Grayson.
Hey, I'm Don Grayson. I'm 92 years old, and I spent 30 some of those years as an engineer for the Navy, a civilian engineer for the Navy. I was basically a branch chief. We call them pedal pushers. I was a GS-13. That means nothing to you except that if you change it over into the military regime, I was equivalent in the Navy as a three-stripe commander, and in the Army, I would be a full bird colonel. So that kind of sets up where you are. That's the very bottom, if you will, of upper management. And I was a vendor executive, if you will. Executive catches all the crap from the wheels. So that's sort of what I did. Now, I managed people like you see in the Big Bang Theory on television. I was smart enough to manage that kind of people, but too dumb to be one, quite frankly. The best way to describe what I did would be a Swiss Army knife. I was good at a lot of things, but never really expert in any one thing. Now, in the 30 years that I was a branch chief, I spent probably maybe a dozen times in the field as a field agent. And what I want to talk about tonight is my very first foreign classified field agent program that I had. Now, most of my field agent jobs were a few days long, perhaps maybe a week, and as long as perhaps a month or so. But in general, the field agent things were one and far between, if you will. And I want to start off by talking about my very first field agent. This would be in the 1960s, early 1960s. And a company in Sweden called Svenska Philips invented something called a spin-tuned magnetron. And they were very proud of that. They classified it top secret, and they were able to get a top secret patent in the United States for it. And if anyone is interested, you can look up spin-tuned magnetron patent, and you can find that patent in there. Now, they were proud of this new invention, the spin-tuned magnetron, and so they invited NATO members to come and see a classified demonstration of it. Now, I got to go through an awful lot of background now. The first thing that you're going to say is, well, Sweden was not a member of NATO in those days. And that's right. But there was a lot of nudge, nudge, wink, wink sort of thing going on. So the United States decided to send three people, one from Patuxent River, Maryland, one from Naval Avionics Center, Indianapolis, me, and one from China Lake in California. Now, all these three people had the requisite top secret clearance, no problem. But we did not have a NATO endorsement. So we were sent to Washington to get the NATO endorsement. And that's what I really want to talk to you about. The briefing was broken up into two different pieces. The first part was boilerplate, if you will, on how to treat classified documents. And the second portion was how to behave. Now, several questions that you're going to have here. What is a magnetron and why would one want to spin it? The best way to explain that is to take a beer bottle and you hold it up, drink it first, most of it, blow over it, and you're going to get a whoo tone. Okay? It resonates acoustically, and the wavelength is the length of the open beer bottle. You drink a little bit out of it, and it goes ooh, a lower tone. You do the same thing with electrons blowing across a tube in a vacuum, and they resonate in very same manner. Now, you have to use a magnet to line up the electrons, so that's why we call it a magnetron. Now, let's go back to our beer bottle. Here it is, and then if we put in the bottom of it a little plate and rotate that plate, spin it, the length of the beer bottle cavity varies. So instead of a ooh, you get a woo, 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 woo. And the very same thing happens in the magnetron. You have a cavity in a vacuum, blow electrons across the top, a little vein in the bottom, spin it, and it makes the frequency of the signal vary. Well, okay, who really cares? And the answer is by varying the frequency, you do away with clutter. What's clutter? If you have a signal up here and you are looking at it, a radar signal, and there's always crap, we call it clutter around it, and it obscures what you're seeing. If you change the frequency of the radar, the clutter moves. And by golly, you can see a little bit better what's going on. Right there in 1960 was probably classified. But this new magnetron was able to jiggle the frequency. There is another reason that you want to change the frequencies. Here's your radar, and it will jump back and forth in frequency. What if you tried to jam it? It's hard to jam. So those are two reasons that a spin-tuned magnetron was very useful. And Savinska Phillips had invented it and invited us to go look at it. So we went off to get prepared for this to our tone in Washington. And the first part of the discussion or briefing was how to handle classified information, foreign classified information. And that was basically boilerplate, nothing fancy there. One of the things they did do, though, was they set up an AUTOVAN number. AUTOVAN, automatic transmission voice, something or other, was a very early worldwide military telephone network. If you were on a military base and you picked up a phone, you'd get a dial tone, and you would be dialing within the military base. You dial 9, the dial tone will change, and you're now dialing outside. If you dialed 8, you would get a warbly tone, and you were an AUTOVAN. So we were given an AUTOVAN number, and that would contact us handling things. And we were told to choose a name, choose the name for this. I chose the name of a fellow high school student that I rightfully assumed would never really amount to very much. He turned out to be the town drunk, and he's died many years ago. Don't worry, though. His son is carrying on the family tradition. So that knowledge is not lost. That was the first part of our talk. The second part is how to handle yourself. And I will always remember the opening words that our speaker said, and they were, "You ain't effing James Bond. Your job is to go someplace, complete your mission, fade into the woodwork, disappear, and come home as if you were never there. And I'm going to teach you how to disappear." That was spy school. How you go someplace and how you disappear. The first thing you have to do when you have a secret is you don't let it be known that there is a secret. And that's kind of fundamental in the whole thing. We are set up with our security arrangements with confidential, secret, and top secret. Now, above top secret, you start getting into what we call black programs, programs that officially do not exist. And with the black program, you do not utter the name of the program. The name of the program is in itself classified. And it may only be inside of what's called a SCIF, Secure Compartmental Facility. It's basically a screen room inside of a screen room, so that no electronic signals can get out. Black programs are all held inside a screen room of some sort. The way you get into the screen room on these black programs that officially do not exist is that you have a personal recognizance. That means that there is somebody that you know and they know you, and you go up to them and you say, "Hello." You give their name and they say, "Hello, Mr. Grayson," shake hands. And this is a personal recognizance officer. For reasons that I don't fully understand, they were oftentimes women, so much so that we often call them Miss What's Her Name. The talk then went on to how you start to disappear. And the first time, or the first thing I should say, that you do is when you kiss your loved one goodbye, you're on a mission. And if you're going overseas, you're probably going to be sitting next to somebody in a plane, train, whatever, for several hours. And they're going to say, "Hi there, what's your name?" And you have to have a cover story. The cover story has to be believable, interesting, but not that interesting. And my cover story was that I am a sales rep for a company that makes small battery-powered motors, vibrators, that sort of thing. Runs on 1.5 volt batteries, two of them, maybe 3 volts, things like that. And I represent the Acme Manufacturing Company. If any of you are old enough, you remember the Roadrunner cartoons with Willie the Coyote. He was always getting a bomb with parts from Acme Manufacturing. That was me. Anyway, my Acme Manufacturing Company makes small battery-powered electric motors and vibrators. We use them in toothbrushes, water picks, small blood pressure machines, that sort of thing. Now, someone's almost always going to say, "Vibrators? Really?" And at this point, you look a little embarrassed. You say, "Well, we just make the motors or the vibrators. Someone else puts these devices into their product." So you've established what you do, and you're a little embarrassed to talk about it. So that's how you start off with your story, your cover story. The next problem you have is when you arrive to your destination. And in my case, there were 3 of us. but you do not travel together. You do not have a government passport. You have a private passport. You do not all arrive at your destination all together. You arrive one at a time, separately. And you go in and you say, hi, I'm here to see Mr. A. And so Mr. A sends his secretary and picks you up. You go to Mr. A's office, and he says, oh, yes, let me transfer you to Mr. Z. And then you go to see Mr. Z, who's the one you're talking to. Your other people, they come and they sign up to go see Mr. B, C, D, E, F, G, whatever. So there's not a big crowd of people showing up. You go in individually, separately. You go to your contact. The other thing that you want to do is to learn how to not stand out. Now, one of the first things that you have to learn how to do is to walk. Americans walk head up, big steps, going someplace. Europeans do not do that. They head down, somber expression, isolated, talk to nobody. There's a story that only a fool smiles for no reason. So you don't smile, somber expression. The next thing you look for is the suit. Look at the thread count of the suit. American suits have a high thread count. Their suits are almost even glossy or shiny. Never happen in a European suit. Thread count European suit is much lower. The suit is fluffier. It's tighter around the collar and around the wrists. You will have a vest probably. And most Americans don't really wear a lot of vests. You look at the shoes, and American shoes are heavy, leather, thick soles. They're designed to go someplace. European shoes are more like slippers, thin, lightweight, that sort of thing. Another thing you want to look for is ties. Ties in Europe usually slant downward to the viewer's left, and that is a historical thing. Comes from the early British Royal Guards. They had belts with straps on them, and they wanted the stripes in the tie to match the angle of the tie and the belt. And then the British clubs, they emulated those club ties with stripes the same way. So American ties, the stripes go down to the wearer's left. European ties, they go down the other way. Get that right now? See, European ties, lower left, American over right. There we go. Now, that rule I just gave you used to be almost inviolate, but nowadays it's not quite as useful. But it's something to look forward to. If you were trying to disappear, you wouldn't want to have your tie stripes go the wrong way. Using those things, you can look at an American just about as far as you can see them and say, that's an American. The next thing you will look for is, do they have a coat, a jacket, an overcoat? Europeans' houses are in general cooler in temperature than American houses. At 50 degrees, you're going to need gloves on your hands. At 55 degrees, you can take your gloves off. The house over there will be heated to probably around 55 to 60 degrees. That's why Europeans of old wore wigs. That was a hat for the house, a house hat. Now, if you have your house cool and you go outside and it's not very cold outside, you don't need a heavy jacket. Western Europe is a maritime climate. The Gulf Stream dumps hot water from the equator on it. And so you have cool, wet summers and cool, wet winters. So the inside of a house is not much warmer than the outside. So you don't need a heavy jacket when you go outside. So Americans, warm house, cold outside, you want a heavy jacket. When the Pilgrims first came to North America, they were amazed at how hot the summer was, a continental climate. And they said, my God, if it's going to be this hot, the winter is going to have to be really warm. And they froze their butts off. If you want an example of not understanding continental weather versus oceanic weather, talk to Napoleon. Napoleon invaded Russia and lost a good fraction of his army because they froze to death. He wasn't used to a continental climate. So that's kind of the beginnings of the things that you have to do. You disappear that way. You don't stand out. You don't do anything that looks obnoxious. You want to be very careful about personal behavior, how you stand, how you walk, how close you get to somebody. If you look at an American, the social distance is about an elbow length, and in England, it's about away. If you go further south and out into the Mediterranean, that distance will get a little bit smaller. If you go north, that distance gets much greater. In fact, if you go to the Nordic countries, you're going to find the distances, social distance, is greater than that in the United States. Uh, Let me give you a cute little example. If you go to Finland, you'll sometimes find this social distance so far apart that Americans will not realize that it's actually a queue or a line. If you go to England, you want to strictly observe the protocol. You do not cut in line. You can almost get in fistfights over that by someone cutting in. The further east you go in Europe, the less that becomes until you come to the Orient in Japan. And in the Orient, a little old lady with wooden shoes will clip-clop past you, elbow her way through, and her kid on her back will kick you in the face for good luck. So that's all different. Oh, in the Orient too, in a crowd, you stand this way, hands up. You do not stand with hands down because there's too much genital carousing. I think that's the proper way of saying it. That's so bad in some of the Orient that they have actual railroad cars, street cars, just for women to keep away from that. So socially, in a crowd in the Orient, you'll do this, not that. So that's some of the things that you want to look at. Yes, in the north, Sweden, Norway, Finland, they are desperate to get some sunlight. They're up north. When the sun comes out, pardon me, when the sun comes out, they will get out there and sunbathe. And if you, in Sweden, for example, at noon, all the worker bees will come out of the office and they will go and get lunch. Now, the serving, automatic vending machines, I guess the word would be, in Sweden are much, much more advanced than they are in the United States. For example, the vending machines will serve you a hot meat meal, a hot cooked meal with meat in it, generally sausage or that sort of thing. And they will serve you hot, steaming drink, coffee, tea, whatever. So the worker bees will come out and they will go to the vending machines. They'll pick up their lunch and they'll head to the nearest park, fountain, or whatever. And the girls will strip down to their pretty nothings and sunbathe. A young red-blooded American boy seeing this will say, I've died and going to heaven. Hi, what's your name? And he'll be lucky to come back with his teeth in his mouth. You do not say hi to anybody on the street, especially a little girl in her pretty nothings sunbathing. You studiously ignore them completely. So this leads you up to a question. My goodness, in any successful civilization, how do you get boy parts and girl parts together? I mean, if you don't, you're not going to have a civilization. And the answer is up north, especially Sweden. If this is sorry that if you have two houses being built, the third house will be a dance studio. And they all go out, and the boys line up on one side, and the girls line up on the other side, and they dance. In a previous reincarnation, I was a dance instructor. I had a great time. So those are some of the things that you have to look out. How you walk, how you talk, how you greet people. Almost anything will get you in trouble. Do not use hand gestures. Hand gestures will get you in trouble almost every time. For example, careful about this. Okay, that's a vagina with how much I want to pay. Thumbs up. Guess where the thumb is? Victory. That's how many lovers your wife has. You and somebody else. On and on and on and on. Do not use hand gestures. In the Orient especially, this is come here nicely. This is come here, we're going to hit you in the face. Be careful of that. In Japan, you want a taxi. Don't wave your hand. You wave one finger. If it's raining, you wave two fingers. You'll pay twice as much. If you wave the hand, you're going to have a taxi wreck in front of you with 5 taxis all wanting you because you promised to pay 5 times the amount. Be careful with hand gestures. Be very careful. Now, it's a little unusual. My background is unusual in that my undergrad background is a major in physics, not engineering, and a minor in chemistry, and a minor in mathematics, and almost a minor in geology. So I've had a very broad background for an engineer. And then my advanced degrees is engineering management. And I had another feature that helped me. The first job that I had when I got out of college was an engineer at a radio station, WEIC, 1270 on your radio dial, home of the Friendly City Broadcasters. Yeah. And I put the station on the air at 5 o'clock in the morning with an announcer. And one morning at about 5:30, he mumbled a dirty word on the air and walked out the front door. I was alone in the building. No one was going to show up until about 9 o'clock when the staff would drag in. He had a 6 o'clock, 15-minute newscast. I ran past the teletype. I ripped off about 20 feet of paper, and I gave the world's worst 15 minutes of international, national, regional, local news, cattle market, stock market, and weather forecasts. Put on the long playing record, headed to the bathroom to throw up. I was so nervous. Phone rang. It was the boss. Where's Joe? Joe's left. He's gone. Give me an announcer. You're doing a fine job, son. Fine job. What else could he say? Well, he never did get an announcer, and I became a combo man. 2 people's job, 1 person's pay. And it was, quite frankly, one of the best experiences, educational experiences, that a young, introverted engineer could ever get. I learned to talk. And after 2 years doing this, being a combo man, combination engineer announcer, I could talk on any subject, anytime, any place, to anybody without any problem. And that's what propelled me into engineering management. Broad background in science, physics, electronics, chemistry, mathematics, and I could talk. And that's why I ended up being a desk jockey, vendor executive, if you will. Now, after you have hidden yourself when you come up to a foreign mission, one of the things you have to be careful about is that everybody is really hot for having really formal dinners. And you can screw up very nicely in a formal dinner without even really doing it. The first thing that you want to worry about in a formal dinner is it an entree? What is an entree? Is this an entree? Entree is a French word meaning enter, meaning in a meal, it's the first part of the meal, the salad or the soup. In America, entree means the main meal, the fish or the meat. Don't mix them up. I've seen people almost get in fights over what an entree was. My best advice is keep your mouth shut. Now, there's a little clue in how to figure out what entree means, and that's how the glasses are arranged across the top. If it's slanted, that's one style, and if it's straight, that's another style. I'll leave it to you to figure out which is which. You're going to enjoy it. The glasses are very important. The first glass is a tumbler. It's a water glass, flat-bottomed with water. The next glass will be a dinner wine glass. It has a stem on it. You hold it by the stem. You do not hold it by the bowl because that would get the wine warm. Oh, okay. What's the temperature of the wine supposed to be? Well, it varies. It's supposed to be the temperature of the wine grotto that your wine is stored in. Oh, it's warmer down south than it is up north. Don't worry about it. Hold it with a stem. The next glass will be an aperitif glass. It will be a smaller wine glass, and it'll have probably a little sweet wine in it. The next will probably be toast glasses. And those are usually little tumblers like a shot glass, roughly. And you'll have at least two of them. You'll have a host toast, and you'll have a group toast. Host toast. What does that mean? That means that when your host gets your eye, he holds up his glass, his host toast. You hold up your host toast. Eyes locked, you both drink your host toast and put it down. What was that all about? And it depends on who you talk to. If you're up in Scandinavia, they say we were Vikings and we want to make sure we don't slit your throat while you're busy drinking. If you're further south, we're businessmen and we want to make sure you're as drunk as we are, so you got to drink it. Well, all right. After the host toast, you will have group toasts. Usually just one group toast glass, but sometimes you'll have several if several different countries are involved and they have specialties like sake. The sake toast glass. And you will have standard, he's a jolly good fellow, blah, blah, blah. There's always a standard to our wives and lovers. May the two never meet. Now, after the toast glasses comes the digestive glass. It will have a sweet wine in it. And then after that, you're pretty well done with things, I guess. You will repair, and I have no idea why you repair, but you repair to either the music room or the library. If it's a music room, traditionally the host's daughter will play a simple tune, or if it's a little bit fancier, someone will have a harp in there, and that's where you do business. So that's the drinking portion of a formal party. Now, there's another portion that you have to be careful about, and that is at the very beginning. When you walk into the room, you find where your seat is. There will be a little name card there, and you stand behind your name card, and it will be boy, girl, boy, girl, boy, girl, and you don't sit down. You will stand there, look around, maybe like a small talk. When your host comes in, he will look around to make sure everybody's lined up. He'll sit down. At that point, you don't sit down. You turn to the girl to your right, not your left. You ignore her. Turn to the girl to your right. You help her sit down. And then you sit down. And then you talk to the girl on your right. Ignore the one to the left. Now, about halfway through it, and this is after the fish, or pardon me, after the salad, after the salad, you'll have, let me see, you're getting ready for your meat. And at that point, you turn the table. And that is a very English thing. Your host will be sitting over here, and he will be talking to the person on his right, and he will obviously turn and talk to the person on his left. At that point, you turn from the girl on your right, and you introduce yourself to the girl on your left. Now, see, now if I have all that right, yeah, that's pretty much the way it goes. Now, as you can well imagine, there's an awful lot of drinking goes on there. There is one more glass that you will oftentimes find, and it will be a full bowled glass, and it have a stem, and you don't hold it by the stem. No, you hold it by the bowl. Why is that? Well, traditionally, it was a mold from the left breast of Josephine Bonaparte. And you hold it as you would a breast, lovingly, warmly, caressingly. Now, there are various rumors of exactly whose breast the mold was made of. Some of it was Josephine, some of it was other people. But honest to God, there are places, Liechtenstein, as a matter of fact, where you can bring your favorite girlfriend and have a mold made and have your own. It's about $2,000. I will leave that to you. But that will get you through most of the drinking. The old hands at the thing will tell you the way you survive this sort of thing is that you eat something greasy beforehand to coat your stomach with grease, so you don't absorb so much alcohol. So that's an interesting little thing. Let's see now. After the formal dinner, my job was to get in an aeroplane with a radar in it, with a spin-tuned magnetron, and we were chasing a target plane up and down the fjords of Scandinavia while they were turning the spin feature on and off. And my job was to decide whether it cut down the clutter or not. And in fact, it did, and it did a pretty good job. So I was trying to fight a headache and nausea, that sort of thing. So this was my introduction, I guess it would be, to my first classified top secret field agent. Over the years, I was on perhaps maybe a dozen of them. Oftentimes it was like this one, where I was going to go to a classified meeting someplace, and the host knew it, but it wanted to keep the fact that there was a classified meeting going on. Other times, the recipient didn't know that I was there while I was there. My job was to show up, observe, fade away, disappear as if I'd never been there. In all of my career, I didn't ever have any poison pens, gimmicks cars, roulette wheels, that sort of thing. Modern spy, if you will, is a very quiet, subtle, didn't happen, wasn't there. No way. So that gives you a quick rundown. I was a generalist, and I was the one that basically kept communication between experts. Experts oftentimes don't talk to each other. I was a generalist, and I could talk to both people and make some sense. I remember one time on a SH-60 helicopter, they wanted to have a high frequency radio communication in there. And the antenna engineer said, well, okay, this is a 3 megacycle frequency. That would mean that the antenna ideally should be 40 meters long, 120 feet long. And there's not 120 feet on a helicopter. So you get around that by putting a base loading coil. You wrap it up into a coil about that big around and about that long. And that's the main radiating portion of your antenna. It has to have a whip on the end, just like your CB radios, to tune it. And the antenna engineer told the frame engineer that he had to have, I think, 20 feet of wire on the end. And the airframe engineer said, no problem. And so they went their separate ways. So when the airframe engineer started putting the wire on there, and in addition to that, the loading coil was about that big around, about that long, and it was outside of the cockpit underneath the rotors outside. And the airframe engineer said, well, gee, that's out there in the open, sleet, rain, step on it, bend it. I'll put it inside. So he put the loading coil inside the cabin. So now the main radiating portion of the antenna was inside the cabin. The outside portion was folded up and didn't work. And they wondered why it didn't work. And I was in a meeting when that came up. And the people had actually not designed a microwave oven, but a high frequency wave oven. And all the energy was going to be dissipated inside. If I was a crew member in there and the captain hit push the talk mic button, I would do this because I didn't want to burn anything up that I had. Well, I interrupted the meeting and said, you got a problem here. I can tell you how to solve it. It'll take about 10 minutes. The admiral said, I'll give you 2 minutes. So I gave a 2-minute discussion of what was wrong and sat down. They thanked me and moved on. Pretty well ties up what I did. Again, I was a generalist that did a lot of different things. Mostly I would go someplace, observe something, fade into the woodwork, come home, write a report. That was really about it. My longest mission was about a month in which I was on an aircraft carrier. We started off in Italy and ran west along the north shore of the Mediterranean. And I was doing, I had a team of people aboard the ship. We had a cargo, what do they call them? These cargo tanks, boxes. They're 8 feet wide and 50 feet long. We had one of those that we turned into a laboratory, and we put in the back of the hangar deck of the ship, the I don't know which one it was, George something or other. George Washington was there, but this was another one. Anyway, what this was the Keynes program, and it's Carrier Aircraft Inertial Alignment System. And the problem is that you have a international navigation system in the bottom of the ship, and you try to move the information up from about 50 feet down up to the top, and then down the carrier deck another 100 feet or so, and then over to an aircraft. And you have to do that as the ship's going up and down, in and out, and back and forth. So that was one that we had to work on. Transit satellites. I've worked on Polaris, Poseidon, inertial nav systems. I helped get to repair those. I kept set up a facility that repair those. I've worked on deep submergence program. I've worked on helicopters, helicopter radars. Helped design a radar altimeter. Well, a radio altimeter, either window really. That was used on one of the helicopters and went after Osama bin Laden. That's how I know about that one. So I've done everything from satellites to submarines and everything pretty much in between. Well, I think that pretty well sums up my background. I can talk to you in detail on any one of these till the cows come home. So if you have any questions, I think now would be a really fine time for them. Remember, I'm deaf. I don't hear very well.
Well, then I posted some questions to you in the chat if you'd like to read them. And I have one. Your father at the last talk was talking about his courier experience, classified courier. And I'd love to hear that again.
She would like for you to talk more about the courier things that you did at Annapolis and on the East Coast.
Oh, that was Keynes program, Carrier Aircraft and Inertial Navigation System. What you have in an aircraft carrier down in the bowels is an inertial navigation system, and it tells where you are. It's updated by satellite. And the problem is that you want to get that information from down there up to an aircraft on the deck. And there's lever arms. The first lever arm is a vertical one about 50 feet long. And then there'll be a horizontal lever arm, probably maybe a couple 100 feet long. And then there will be a lateral lever arm of maybe 50 feet. And sometimes that lever arms bend because the ship is not rigid. And the whole thing is pitching and tossing. So my team on that particular time was trying to develop a way of getting that information from down below, up above, clandestinely, without a lot of cables and wires, in the midst of a lot of interference from big radars, that sort of thing. And what was the president, John somebody, brother, I can't think of the name. George Washington came up. They came up through the through the Suez Canal and met us, and we were on a goodwill tour west from Italy, and we stopped every once in a while, and we had a few demonstrations. The classified portion about this was the fact that we were doing it, how it was done. We were put on the hangar deck. This shipping container was put on the hangar deck in the aft end of the ship. We had a guard in the door to keep other people out. And my team worked in there, working on programs that can do that sort of thing. That cruise took about a month, if I remember correctly. I had never been on I was on a destroyer when I was in the Navy, so I was used to small ships, and you can get lost on an aircraft carrier. I had a PhD or three masters, a couple of women, and I had to have set up quarters for them, keep things going, interface between them and the ship, that sort of thing. That was a branch chiefing job, but it was a classified mission that we didn't tell people on the ship basically what was going on. That's why the guard was on there. We were doing something exotic, and that was how that one went. So that was one of them. On Polaris Poseidon, there's an interesting question there. Polaris Poseidon has inertial navigation systems, three of them, they're set up orthogonally like this, and they spin, they're mechanical, and they're an inertial system, and they will stand in a missile for perhaps several years. And every once in a while you spin them up, see if they work, and then after that, they wear down, the bearings go. So they would ship them to Naval Avionics, and so Roy Wilt was the branch chief for that job, and his job was to take these inertial navigation systems, replace the bearings, retest them, and ship them back. And the way you test them is you turn them on, and you see how fast and how accurately they find true north. That meant that Roy had to have in Naval Avionics a line that was exactly true north. I mean, right smack dab down the middle. So he hired a professor from a college that I'm not going to give you the name of, who was a survey expert, PhD in surveying. He came in and surveyed a line. Now, the way you survey a north-south line is that you look at the North Star and you sight on that and you transfer its direction down to the floor of where you are. You put 2 marks in there, and there were 2 marks, well over 100 feet apart, and the floor of Naval Avionics was true north. Now, the surveying professor, he did not have a good background in celestial observations. And Roy knew that I had an interest. I had a fantasy at one time, many years ago, of getting a sailboat and sailing the world, being a free spirit. In order to do that, I taught myself celestial navigation. That's a non-trivial skill, let me tell you. And Roy knew that I knew something about celestial navigation. So he said, "I want you to look at this paper that the professor wrote." Okay. And the professor did a good job, but he was not really good at celestial observations. For example, when you look up at a star, you're looking through the atmosphere, and you're looking at an angle at about 40 degrees for the North Star. And there is the sphere, and you're correct for that. Well, he knew about that. And he looked in the nautical almanac and got the correction for 40 degrees. 40 degrees. 2 small mistakes were made right there. Number one, Naval Avionics was not at 40 degrees. It was at 39.9. Trivial error, but an error. Then he got a number from the nautical almanac. And what is the expected altitude of an observer in the Navy? 0. And Naval Avionics was not 0. It was the 600 feet. There was another small error. The North Star is not quite north. It's 1 degree off. It goes in a circle, which means that it will vary from 39 to 41 degrees. And so your refraction error will vary. All in all, I was able to reduce his error budget by 50%. I was pretty proud of that. So I gave it to Roy, and Roy thanked me, and that was the end of it, I thought. And about a year later, I had reason to revisit that. I said, Roy, can I get a copy of that paper that I wrote about a year ago? He said, well, no. That paper's been classified top secret. You're not officially on the program. You don't have a need to know. I can't make a copy and give it to you. I thought that was pretty funny until I thought about it and I realized that I could take my figures, I could work them backwards, and I could tell you exactly how accurate Polaris Poseidon missiles were. He was right. I had no need to know. So that was a funny one in there. And I'm not going to tell you the college that the professor worked at.
Did you really call the cover story Acme? And wouldn't that create more questions?
I did call it Acme, and no, that didn't cause anything. The whole idea was to be slightly embarrassed about it so people wouldn't bother you. It was a believable story. Maybe I was into kinky personal vibrators. Who knows?
Another question. How did living a double secretive life change your ability at identification? Were you given multiple driver's license or a pilot income tax statements, for example?
Oh, no, 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 no. I did not have different driver's license. I did not have a different passport. I was so small, innocuous, uninteresting as to be invisible. I did not, and still do not, belong to Facebook and all of these social things. Live quietly, disappear. Don't make waves. I was never there.
I have one more. How did a spy career change your worldview of things, personally and politically?
Oh, I'm not sure that it did change it. I was a pretty low level person, not involved in politics. I was involved mostly with weird technical issues that were unusual. No one fully understood, and I was good at taking things that were different, like chemistry and mathematics, like physics and zoology, like things that were totally different, and find a correlation between them. I was good at taking experts at various things and getting them to talk to each other, just like the SH-60 helicopter uh, radio communication device. The airframe man and the antenna man didn't talk to each other. So I am good at finding different disciplines and blending them together. One of the fascinating things that I'm finding right now, and I'm working on some talks on that, is Moiré patterns. If you ever drove by a picket fence and looked at a picket fence through a picket fence, you saw a moiré pattern. That is a visual moiré pattern. But you will find any time that you have two functions that interact, the interaction is a moiré pattern. And they follow exact rules. And I can demonstrate an optical moiré pattern, a mechanical moiré pattern, an audible moiré pattern, even a celestial moiré pattern. So, oh yeah, I may well be talking about moiré patterns at the Mensa Weem, I believe it is, in Chicago. I'm going to try for that. Fascinating subject: moiré patterns, mechanical, electrical, celestial moiré patterns. It ties more crap together than you shake a stick at. Anyway, I had a alt, and I hate to call it a radar altimeter because it was not radar, but it was a scanning device that scanned horizontally and scanned vertically, and you meshed the two together in a moire pattern, and you could get a picture, a up angle, right angle, exactly like looking through a window. And the view that you would have of this looked very much like you were in the Smoky Mountains in the evening, looking across the mountains, and you could see the hills and the valleys. And as they got further and further away, it got dimmer and smokier and so forth. It was an altimeter that gave you a picture, and it took exactly zero training to learn to use it. And it looked very much like I said a Smoky Mountain picture in the evening. Instead of being blue, we had a green screen, but don't tell anybody. That was the phosphor color. But anyway, that was used a moire pattern, and you had to make sure that this sensor spinning this way and this sensor spinning this way meshed together properly. And it is a long discussion about that, too long to go into here. But that was a nice moire pattern thing that we pulled together.
I think we have time for one more question. You said one of the things that you were supposed to do is observe. Were you collecting classified or information of some kind, as a spy?
I cannot talk about that one. Okay. I'm sorry. I probably cannot talk about that one. I follow things very carefully, what I can or cannot talk about. Let me give you a cute example. We are at the point now where we are designing airplanes that are so good at not reflecting radar waves that they actually act like a hole in the environment. They're not there. And you can take, and this was unclassified about a year ago, you can send a radio wave toward an object. Here's your object. Here's your radio wave coming along here. And there's nothing there. There's no reflection at all. But since there is nothing there, it will refract around it and move on. And that refraction around that is a moire pattern. And you can have a receiver over here detect the moire pattern. Now, you cannot tell where it is, how fast it is, or anything about it, but you know it's there. And that was highly classified, and just last year, a paper was written in England about that it can be detected. So I watch things like that and know when I can and cannot talk about them.
Well, thank you very much, Dawn. This has been a wonderful, interesting presentation. I'm sure everybody here is very excited about it. Thank you for talking to us.
You're quite welcome. Just keep in mind, you ain't effing James Bond.
I think that was great. That was a good way to introduce it, and we heard so much of your experiences. It's really wonderful that you could share this with us. Thank you.